Looks like Tuco and I are both ready to get into another stream. You want to play, little guy? The shop is warming up. I've got my cup of tea, and Tuco just finished a nap, and I think now he wants to play. Oh, let me get some more bandwidth going. Okay, that's a mistake I keep making, is forgetting to pause my backups before starting the stream. I keep doing it right after, so it might take a sec for the video to clear up, but it should be momentary disruption at most. So hello everyone. Having a pretty lazy kind of post-holiday, so I'm still off from work today. We had kind of a little holiday kind of Christmassy get-together yesterday and the day before with friends. That was nice. I don't really see family anymore. Oh, Tuco, what kind of jump was that, honey? Where did he go? Okay, which button do I want here? Hey, cat. Yeah, so Tuco and I actually both went to a friend's place for Christmas yesterday, which was nice. But I think he's happy to be back here. Oh, so confused. Thomas in chat says that was noticeable straight away. You mean when I stopped the backups? Anyway, hey Tuco. So anyway, the cat seems to be in a good mood. And I wanted to kind of try to finish this project today, the one with the little flexible circuit board and the squishy buttons and stuff. So I've done a couple more prototypes since the last stream. Let's see if I can get those on camera. You might hear some weird noises. There's actually a crew of people working on the roof today. I was surprised that they would be starting right away, but I was like up late last night at this friend's Christmas party, and then this morning, it was like 9 a.m., there were people with power drills on the roof. So, see if we can aim that slightly better. I don't know why the camera says it's only at 2 bars of battery, because it's like on an AC adapter. Whatever. So it was nice having a little get together with the chosen family yesterday, and another little thing with some of the neighbors here in the warehouse the day before. I don't really see family anymore, but it's nice to have some people that you're close with that you can hang out with. And so this thing yesterday at my friend's place, Tuco and I both went. So he doesn't go out of the house super often, but I think he appreciates the occasional adventure. So you may have seen this doodad before. This is like a flexible, just kind of a special purpose keyboard that I'm building as a kind of project both for these videos, for material for these videos, and as something I can use during these streams. So the idea is this is going to be flexible so that it can curve around these curved light poles that I have around here. And I'll embed magnets in it so that, hey boy, I'll embed magnets in it so that this will just like stick wherever I want it. And so it'll be a matrix of buttons that I can use to switch between different video channels on my setup here. So this is a flexible circuit board that we made in CAD and cut on a mill out of this Pyrolux composite, which is Kapton and copper, and soldered on buttons and resistors and this teensy microcontroller. And so the main remaining steps here are doing the CAD model and 3D printing for the enclosure that goes around this, and actually kind of updating the code on this. I have like a proof of concept firmware for a smaller button pad, but I suspect I'll need to update that a little bit for the nonlinearities in kind of the components that I'm using here. So it might just end up needing to have kind of a lookup table with analog values corresponding to all the buttons, but that would be fine. It doesn't need to be elegant in that case, it just needs to work. I mean, the software needs to work. I'm more interested in the visuals looking elegant. Hey, Tuco. Because I do like how the Kapton, how this kind of flexible circuit board came out. Tuco, you sure are looking around for something. I like how this came out, and so I was thinking about building the kind of 3D printed flexible surround out of clear NinjaFlex. So that's what a lot of these prototypes are. This was the very first experiment. Kind of learned a bunch of things from this. This was testing a couple of different concepts. I'd picked a shape for these button tops, kind of made them a particular diameter cylinder with kind of a rounded edge and kind of a spherical indentation for the finger to rest in. And so the button top feels pretty nice. I tried to make a, oh, maybe this is not autofocus time. Oh, Tuco. Tuco's distracting me. I think Cat Cam is not covering the action here because he's being a bit of a menace. Are you going to hang out on the chair after all? Maybe he is. Okay. This cat is usually so unpredictable, so I'm surprised that his hangout on this chair has been so consistent when I'm streaming. Yeah, man, this cat, he and I really get along with each other. I also just noticed, slightly catching up on chat here, there's a question from Microhex. I forgot to ask, but where did you get your Pyrolux? That's a great question. And I think I just found it on eBay. I don't remember the specific seller, but I think I just searched for Pyrolux. And it was a bit annoying because it wasn't easy to get in just like a really small sheet. I had to buy like a fairly big roll of it. Not like amazingly big, but I think the roll was, well, let me just get the roll. I can show you what it kind of came to me. I've been keeping it in this poster tube to kind of keep it clean. But yeah, this isn't what it was shipped in. I don't remember exactly what it was shipped in, but this is just what I've been storing it in. Focus. So yeah, it came kind of like this. I think this was inside of some padded thing in a like larger tube. So it's not like a very large roll. Let me see if I can get this better on camera. So yeah, it's autofocus. So yeah, whatever this width is, it looks like about 20-something inches, maybe, or like half a meter. And then I think the other dimension on this roll was maybe 2 meters. So yeah, something like a meter, maybe 2 meters by half a meter. And I think I paid something like $150 for this roll on eBay. So it's like a lot for a single project, but I was interested in doing a bunch of things with these. In particular, one thing that I really wanted to try with this was to, because this has such a nice thin insulation layer on it, I wanted to try bonding this with a thermally conductive adhesive to aluminum, and then milling both this and the aluminum on the machine at the same time, or in separate passes. So, and then the aluminum would be a nice substrate for like high power LEDs. So I was thinking about using that for making like custom high power LED fixtures using like surface mount multi-watt LED packages. Because I can mill aluminum here, and that would be a really interesting project to try to do something 2.5 dimensional with that medium. And then, I'm trying not to put too many fingerprints on this, but you can see this, I mean, the top surface of this looks a lot like a normal FR1 or, FR4 PCB. It's just like a nice, smooth, consistent layer of copper. And then the other side is just this thin coating of that Kapton. So it's like they just drew out a copper sheet and then, like formed this coating on the back of it. So the whole thing is very thin. I'm going to get it under the calipers for demonstration. I think I might have done this already, but on a smaller piece. But those calipers are zeroed. Should I get a bunch of it in there? Yeah, 0.1 millimeters thick, almost exactly. I can compress it down to maybe 0.09, but it looks like it's intended to be 0.1 millimeters. So yeah, fun stuff. Oh, nice. From the chat, found a seller where a 6 by 4.5 inch piece of Powerlux is $12. So that sounds pretty nice. A good size piece for experimentation if you don't plan to make too many mistakes. Oh, it's finally starting to warm up in here. I put on all the warm clothes and I'm sitting next to the heater. I know I'm such a wuss. I used to live in Colorado where it was much colder, but I just don't like it anymore. Anyway, back to some of these prototypes. So this is the one that I designed on the previous stream. Oh right, the autofocus sucked for this. So the button shape on this feels pretty good. And I think I did a reasonable job of designing this to avoid the resistors on the circuit board. But there were still a couple of problems with this design. Most notably, the button is way too hard to press because what actually ends up happening is there's like a kind of dome, or not a dome, but like a truncated cone shape with thinnish walls holding up the button. So for the button to press, that is actually a strong enough shape that it doesn't just want to crumple, it actually wants to roll. And as it rolls, it wants to push out farther through the bottom than it actually can with the Powerlux there. So when you have it down on a hard surface, it just, let's see if I can get that on the camera. It doesn't feel very good. Oh, wow, that's contrasty. Let's decorate this frame with some things that aren't painted completely black. So, yeah, you can see this like works, but as I push it down, the surrounding wants to ride up a lot, which isn't good. And it's just like way too tough. It's not pleasant. I was also trying to play with kind of bulking up the Z height of this whole assembly using these struts and then hanging another thin layer of NinjaFlex over the top. And that was an experiment to see whether I could make the whole thing appear thicker so that, that this surface wasn't such a, because like imagine if this surface had just gone straight down, the button would just be this big like pencil eraser thing there that would just kind of be, I don't know, I feel like it would kind of feel like too sticky outy and it would just be kind of prone to like, stresses and I'd like want to pick it off or something. I don't want a button that feels like a scab. I want a button that feels like, a small indentation that I can push my finger onto. So this was my attempt at, well, okay, let me back up slightly. The constraint that made the button so thick in the first place was a test that I did where I looked for the thinnest layered multi-layered piece of NinjaFlex I could make that I could put directly on top of one of these really clicky tactile switches, and it wouldn't feel like kind of the the bowling ball under the mattress, that it would still feel like you were pressing a wider button surface. So mechanically what I needed was a high enough, a tall enough chunk of this squishy material so that when you squish it from the top, the force from that little button underneath diffuses over a wide enough area by the time it reaches your finger that it doesn't feel like a little, annoying nub in the middle of the button. So that test led me to the buttons being this tall, which led me to want to create a surround around the button that was almost as tall so that it wouldn't feel like such a discontinuity around the buttons. So this does a reasonable job of kind of retaining some of the flexibility, but it's still going to be a little weird, like trying to wrap this around a surface and trying to flex it in multiple dimensions. Not nearly as bad as if this was like a solid fill, but I still don't think that's going to have the flexibility I'm looking for, so I think I need a way of keeping the whole thing thinner. I made a couple of other prototypes, not off camera, but off stream, so I'll get these into a video of some sort later. I still don't know. Well, I think the most immediate use of this footage is probably going to be for more of like an assembly commission kind of video, but I think this project is probably going to be interesting enough to turn into a separate video too. So I was trying to work on, let's see, which one of these actually worked. Yeah, I'll have to go through some of these CAD models maybe. But I was trying to make basically a surface. The cross section of this kind of looks like two collapsing levers. So there's a fulcrum. I should just draw this. That would be probably easier than finding the right version of the CAD model that had this particular outline in it. So let's say if that's the kind of flat surface this is all built on. I had a profile that went like, so it would start to come up, and then it would form this kind of middle, I guess I'm drawing it as kind of a dome here, and ideally it would be a dome, but really it had to be kind of flat across to print properly. So this was like a flat across, and then kind of a curve, and on the other side something similar. And then, but I still wanted the button to reach kind of a wider profile to feel good on the finger. So then I had another piece that kind of came out like that and kind of formed the top surface of the button. I'm drawing it a little bit suboptimally there, but, and then I had this kind of hollow in here so that basically when you pushed on the middle of the button, this force would end up getting directed toward the little button here, and its kind of corresponding pressure would end up being diffused over a wider area. But then the outside of this also formed kind of a nice cylinder, so that kept the button top rigid. And then this curve right here kind of coupled that cylinder to this lever pretty loosely, so that as you push the top of the button down, that also collapses along with this. So that is, well, that's a design I kept for a couple of these. This is the first one. So can you see any of that? These details are really hard to see once it's printed. But you can see that this actually has this curve inward where there's room for this to collapse. The hollow is really hard to see here. But if I put that down on a hard surface and press it, then, so it still kind of tries to ride up a little bit. Let me try to hold it down with magnets just so that isn't misleading. Because I think this stuff is so flexible that the edge conditions in your test setup definitely affect things. So these are like all the magnets of this size that I had. That was my constraint in figuring out where to put the magnets. This is how many I've got. I think 16 should be enough. Those two are just stuck together. Oh, you can hear the people on the roof probably. Or at least I can pretty clearly. So, yeah. So you can see there, like that, I mean, it's hard to visually communicate how much force this takes. It's maybe a little more than I would like. But this was like enough for me to kind of continue with this design for a few more iterations. Let me try to show it with a button underneath. One problem already with these, especially just in testing it, so this bridge does not really print cleanly. I think I tried improving that in the next iteration. And I wasn't actually like looking at the printer while it printed that particular part, so I'm not quite sure what I need to do to fix it. But I think I just ended up switching approaches anyway after a couple more iterations, so it didn't end up mattering. But one of the issues that creates is that, you know, if there's a little gob of material that is off center, then it'll hit the switch body before the middle hits the switch button, which causes it to feel incorrect. Like, it means that instead of feeling the switch push down nicely, you're actually feeling the top of the switch deform, which is much harder. So it creates totally the wrong feel. So this style of button is super sensitive to how well it's lined up. That feels okay. And so if I hold it down like that, one other test that I've been doing with these is to hold down the button and then kind of poke it with a pencil off center to see how well it transmits the force even when you're not pressing directly down on the button. So, see if that still works. So that feels all right, actually. Like, that feels like a button I wouldn't mind using. Let's not draw on this. But, you know, like off center, it doesn't actually work at all because there's nothing holding the button in like on axis. So, and that's fine. Like that wasn't really part of this design. I think after that, I tried incorporating this kind of sloped surrounding. So there's maybe about a 0.5 millimeter or 3/4 millimeter clearance there. So the idea is that usually that moves freely inside of that outer cylinder. But you know, if you press off cylinder, then it'll kind of rub against it to roughly constrain it to move up and down. So let's see if I can line this one up. Not sure if that's right. Anyway, that feels all right. I mean, it doesn't feel like a nice keyboard. It feels like, you know, a button on some cheap piece of 80s equipment, but it feels tolerable. You know, it kind of drives me to make something better, but I could totally deal with it. Some nice aspects, you know, the surround actually feels nice because when you start pressing too hard, your finger starts resting on that edge, which is much harder, and, you know, it kind of feels like a reasonable end stop to the action. If I press with my finger on the edge like this, then it actually doesn't press on the button enough for that to trigger, so I do actually have to press my finger reasonably centered on the button for it to actuate. Let's try the pencil again. Feels good in the middle. maybe it's not quite centered, but it's like it actuates pretty well at the sides over here, but not so much at all over here. And so in this design, the feel is definitely better. I think it looks all right, and it's still kind of hard to make, primarily because of this bridge not printing cleanly, and so you have to be careful about plastic gobs not ending up off-center and causing the button to malfunction. And that's potentially something fixable. Like there are workarounds to make that bridge print more cleanly, and I tried some of that in this design. Not quite sure how well it worked. But I think a lingering problem with this is it's still just so thick that if I want this to be wrapping itself around a pole and actually curving, then I don't know if I can rely on any of those characteristics in this button to keep working. So yeah, there are some competing constraints here. I want the whole thing to be flexible, but I also want this force spreading ability. So when you press on the tops of the buttons, it feels like a larger surface than just a tiny nub of brass. And I want the whole thing to be able to flex onto curved surfaces, but the button caps still need to have some ability to transmit force in a rigid manner. So I think I'm going to try going with these little plastic inserts. I think this design has some problems too, but I think this is a step in the right direction. So this is designed so that it has a little kind of centering indentation that fits right over the little brass piece. And the goal with these is that you should be able to, if they're supported by something kind of squishy around this ring, then that would hold them such that if I press down over here, then you could have a support that prevents that side from going too far down, and then would distribute some of that force back toward the middle. So I think this concept would let you make a button that feels pretty nice and still keep the whole assembly really thin. I mean, now the whole assembly's thickness is really just limited by, this part plus just a minimal amount of plastic between the top of this nub and the top of this surface. So I think I made that thickness in this prototype 0.3 millimeters. So that's 2 layers at the layer height that I'm printing. I could even go with 1 layer maybe. This design still has some things that concern me. I think these buttons, I'm going to have to be really careful about how I hold these buttons into position. So I'm imagining something like this fitting into kind of a groove in the NinjaFlex that would hold it in place, so that, and this would be kind of encased with the kind of rubbery coating. So I would still be able to print, interesting keycap textures in the NinjaFlex over this, but this would sit under it and do the job of diffusing the force over a larger area without having to have such a thick amount of material. But I want to make sure that I can have the flexible material underneath it support this in a way that prevents it from bottoming out unevenly like this. I also want to I want to make sure that this doesn't limit the flexibility of the overall assembly, because you imagine the whole thing flexing, you need to have the supports for this piece tolerate the whole thing riding up quite a bit. But it also needs to hold it without rattling around. So I'm imagining something where there's a like a groove in the NinjaFlex that this snaps into, but then that whole assembly is kind of coupled as loosely as I can to this base, so that I can, there's some room for it to extend, so maybe there are pleats in it that wave up and down a little bit. The other problem with these is I think they might need to be larger in order to fully clear all the solder joints. I tried to, I didn't really model the solder joints in CAD. I think I probably should, because they take up more space than I think I've been accounting for. And I think I could make the whole thing wider in diameter to clear the solder joints on the switch, but that would make them actually pretty big and maybe even just aesthetically too big for what I'm going for. So another option is to make these rectangular instead of circular, which might just be nice in general. And then I could make the buttons, kind of narrow but taller rectangles, or some other shape that has, I don't necessarily have to make them a simple shape either, since I can 3D print the inserts in whatever shape I want. But I'd like to try to keep the inserts simple, just so that this thing is a little faster to design. And if I make all the inserts the same, then I can just print a bunch of them and take all the ones that worked out the best. Since sometimes these little shapes, if you have a little printing imperfection, or with these, I actually had trouble with just using the scraper, getting them off the printer. Some of these just got dinged up on the side so much that maybe I wouldn't want to use them. I'd want to print some extras so I could accept some losses. I could also print these in different colors. Since I have the translucent NinjaFlex, then I could have different color buttons. And I don't have a lot of different colors of 3D printer filament here, but I could at least have a couple of different buttons, or do the rows in different colors maybe, or the columns in different colors rather. Or maybe do alternating rows. That could look nice. Maybe do them in purple and black. A couple of responses from the chat. I'm not going to teach anyone how to build a bomb. That's a silly question, and I'm using OBS to do the streaming. And it's pretty good. I don't have it running on a really powerful enough computer right now, so it's a little laggy sometimes on the complicated streams. But yeah, the thing that's doing the setup right now is kind of interesting because it's capturing like the viewfinder output from my camera's HDMI, and then because I want the actual center to always be opaque. But the rest of it, I kind of want to not waste so much screen real estate on these little odds and ends, because like the full frame image coming out of the camera is actually like got a big black border with all this other stuff in it. So I do a combination of chroma keying and then adding in a mask before chroma keying so that the chroma key avoids the actual image area. And I'm sure that sucks up some CPU also, but I'm doing it at kind of a low resolution, so I think it's worthwhile. Oh, right. Yeah, I think maybe it's time to do CAD and... yeah, maybe making... I think I might just start out by trying to more accurately model, like just leave some room for the resistors and solder joints in the CAD model just so that I can play with the buttons effectively in there. And then, stop that. And then we can go back to CAD. I've also got a bunch of stuff in CAD that isn't on here yet. Like I was experimenting with the design for the outline of this whole thing, and I've got a placement for most of the for all the magnets that I think I like. So, oh, where was that? That was over here. Oh, this CAD is so peaceful. All these little pieces. It's so frustrating when it doesn't quite feel right, because it's like you just, I don't know. How do I describe it? Like, I guess it's partly just this visceral, like, this does not feel like I want it to feel, and partly this, like, worrying if I've, like, destroyed the tactile switch somehow. But I think usually when it feels that way, it's an artifact of this, the plastic surround just touching somewhere it's not supposed to on the solder joints or the resistors. And I think it's just different between the different buttons because Some of the solder joints are a little bit taller than others. Anyway. I imagine you can hear that, that drilling. Alright, let's go back to this file. Oh yeah, I guess I do still have that profile up. That napkin sketch I made is basically this piece. So this is the bottom, this is that first lever that collapses, and this is the support for this part of the button. And this cut actually just is kind of a topology hack that allows this to be a single closed polygon instead of like a polygon with nested cutouts, because it's just less annoying to deal with in many steps of the operation that way. Alright, let's go into these buttons. Yeah, I think that's just what I want. Now, I'm going to try to just measure like the worst example I can find, just to give me a pretty good bounding box for these. That sounds like an air-powered grinder. Giving these solder joints plenty of room. That's 2 by 3 millimeter rectangle, 0.8 millimeters in from the edge. Oh man, usually when there's construction this loud, I'd just put on music, but I don't think I have any music ready to go right now that I can easily stream without getting into trouble. So many different ways this stuff could be done. Let's see, how thick do these need to be? Oh yeah, here's a really bad one. I think that's how I practice engineering, is just by making as many mistakes as possible, and then, you know, making that my future job to fix the mistakes. Is that like a millimeter? A whole millimeter thick? This would be easier to measure if I had a smaller piece of paper here. So let's zero this on the paper. Oh, that's worse than a millimeter. That is like 1.3 millimeters thick. Let's see what that looks like. I mean, having more room to accommodate errors in both the soldering and the 3D printing in order to make the buttons feel better is probably a good idea. So, 1.3 millimeters. Oh yeah, that's about just as high as the... That's a coincidence, isn't it? Yeah, that's the same. I guess I just managed to measure the same height as the button itself. Which might have just meant that my calipers were resting on the button instead of the solder, but they looked like about the same height, so that seems safe. And now, make some copies of this. Alright, and the resistors are not the same everywhere. I didn't have a way of like consistently laying those out on the circuit board. I just kind of dragged them into about the same spot everywhere. But I suspect with the amount of clearance we want to leave around the solder joints anyway, that that's not going to matter so much. Yeah, some of these are significantly bigger than they need to be. Oh, let's pay attention to the layer for these. Maybe a new layer for SMT clearances. It's as good a name for this as any. Yeah, it can be purple. So, where are the resistors relative to all this junk? I'll call it 9¼ millimeters down from the top edge of the switch. Yeah, that's 9¼ millimeters. I think the keep out region for that resistor is going to end up merging with the region for the leg of that switch, which is fine. Let's give that like 4.75 millimeters. 2.75 by 4.75. That is resistor land. I do actually want that centered with that. Okay, I don't care about booleaning these together, because they're just going to be for guide purposes. Alright, let's go back to making switch pieces. So now we have these guides on all of the buttons that show us where we should leave room for the electronics. The electronics aren't that big, but that's going to give it a conservative amount of room. Might need to make some of these bigger, actually, because the resistors are a little farther away. Let's make that even slightly more conservative yet. Yeah, so I think what I want to do for these switches, like, I still kind of want to make them circular, but underneath what I might do is, you know, might want to have the keycap still be circular like this, but have them actually be supported by just a couple of points on the edges here, so that can, you know, I can offer it a reasonable amount of support so that it stays kind of centered in the right position, but I don't actually want these supports to actuate the tactile switch. You know, I want them to hold it really loosely. You know, basically my goal is for something that has a pleasant and uniform appearance and tactile function even when it's stretched over a non-uniform surface. And that's certainly going to be hard to do absolutely, but it'd be nice to try that out. So this was my previous iteration of that. There's a question about if I'm using the 3DX 70040, is that this thing? I don't recognize that model number. If you're asking about the mouse I'm using, this is one of the 3D Connection Space Mice. It's the Space Mouse Pro. I still haven't really gotten used to using the buttons on this thing, honestly. So I probably would be just fine with the smaller Space Mouse that doesn't have the buttons on it, because I still just muscle memory kind of go over to the keyboard and use the modifiers there. Yeah, I mean, if you are asking about the Space Mouse in chat, I like it a lot. It definitely speeded up my CAD quite a bit and made it more fun when I started using this. I also find it nice for doing CAD that I'm getting on video because it makes it more interesting to do, like, kind of move around the camera and not just have to, you know, I feel like I can be thinking about how I want to view the model while at the same time thinking about how I want to be editing it, which is nice. So, I think I want to keep the top circle from this. I mean, there are parts of this design I want to keep, but there's also a lot of this I don't like. So I want to cut this apart. I'm going to cut this right here. How loud is the hammering on the stream? Oh, let's go back to the default layer. I mean, I think I still like this part. Well, that's actually not true. I don't like this part either. I mean, I kind of like the circle, but I think it should even be slightly wider. So I'm basically not going to throw away all of this. How wide is this? This is 10 millimeters diameter. I think I actually want 12 or 15. Let's try 14 millimeters. That seems too big. Let's try a 12 millimeter button. Kind of like that. Okay, let's make a layer for these force spreader pieces and just design them in the tack switch block so that I can replicate them easily. I can easily just see what these look like on all the buttons at the same time. Force spreader. Or how about rigid inserts? Sounds better. Hello there, hammer. I forget what the easiest way of getting an object into a block is, but I think I'm just going to try to cut and paste. I think that worked. Yeah, and now it's on all the switches. Great. There's a lot of stuff I want to do for these switches not in these blocks because I want to be able to have some kind of customizable texture for each switch, but especially during this stage of the design, this is super helpful. And parts like the force spreading kind of rigid insert here, you know, I think these will be the same on each switch, so it's fine. So one other thing I want to try here, since, I mean, one thing I was trying to achieve before was to make them radially symmetric so that if they were fitting into a circular groove, I wouldn't have to worry about what direction they were spinning. But since I'm committing to making them no longer spinnable now, I can think about some different design choices. And one thing I might do is, instead of having this whole thing be kind of a thick solid, I might use more like more kind of plastic cross braces to make it rigid and keep that from flexing. So what is the thinnest I really want to make the top of this? I think the thinnest I want to make it is like 0.3 millimeters. Which is pretty nice. I mean, that'll just be a thin layer of plastic that gives that a smooth top, and then I can add some additional reinforcement underneath it. Probably in the form of kind of a plus-shaped cross brace, and then a thicker edge piece in some areas. And how big do I want to make that cross brace? Probably at least another 0.3 millimeters. Let's look at it from this axis first. So that whole top of the button is 2 millimeters wide. I'm thinking like 0.6 would be enough. We could do 2, could do more than 2. Let's try 3. That gives it a nice kind of hexagon shape, which is cool. I like hexagons. So Let's make another circle that's inset from this a little bit. Let's use 0.3 for this also, or sorry, 0.6, I guess. Yeah. Okay, now we can make this a little nicer. Curved Boolean. Y. Oh, I forgot to select that rectangle. Oh, right. Let's not keep those outside pieces. All right. So these are all separate curves now, which is a little bit annoying. Although actually, I think I can just fillet all of these. 0.5? Yeah. So I think I'm going to avoid making any kind of indentation for the top of these buttons, because that's just going to reduce the distance between the force spreader and the top of the button, and it's just, I think it over-constrains it. You know, I think I want the constraint here to mostly come from the edges here, but then when things are flexing, if this has to slide against the top of the button, I think I want to allow that. So, and you know, it wouldn't slide enough to where that button nub would get stuck all the way over here, I hope. That seems fine. Kind of part of me wishes there was a strut going straight vertically too. This is probably fine. Let's extrude these maybe. And I think we wanted 0.3. That looks like the same height we were aiming for before then. So I kind of like that. That's our insert. And so it has a couple of jobs. Like, it's got to be rigid so that when you press it pretty much anywhere, it transfers the force to the middle of the button. So I have to think about how to anchor it so that, you know, no part of this exterior can go too far down, but I'm also holding it lightly enough that the whole thing stays flexible. So I'm imagining something coming up here out of the Ninja Flex to give it like something to rest on. But I can also make this whole thing much more rigid if, like, I take advantage of all this space on the two sides here. You know, that's nice and compact here, but, you know, I think I could build some kind of structure out of the bottom on these two edges that makes it more rigid and helps it, you know, helps me mount the kind of end stop bit lower so that the whole thing has to, like, I want to get this closer to the surface as fast as I can, because that makes, that means there's less of an impact to the flexing. So in fact, if this kind of moved inward, first, then I would have a narrower, you know, I don't want to make this thick, right? So if this goes straight down, now I'm creating like a box that's difficult to flex. But if this kind of comes down, or if this kind of goes over and then down, then that whole surface is more flexible because that this edge here can then just kind of like angle over instead of having to stretch. So, and I'm printing these with this top surface down on the bed, so I can do some fancy stuff down here if I want to. So it feels like this should come over, it should be curved, it should leave enough clearance vertically so that the button can travel fully, but also leave enough clearance so that I can build up enough of a kind of squishy substrate here to provide like an end stop for the button's travel. I think these buttons have the potential to feel much better than the last prototype. I think these are going to be nice. So go over something like that. Probably just like a simple like loft between a couple of curves. Not quite sure what to do with it at the bottom, but I think I'm going to deal with that later. I just want to see what this looks like. And then, because I'm probably going to have to cut it at some point to make room for something in the NinjaFlex, but right now I'm just going to take it kind of arbitrarily far down just to see what it looks like. So, so this is just going to be a reference line for, I think, kind of how close I want to take this particular piece at most. And now I'm thinking more critically about how much margin I actually want, because what is this margin for? This is for kind of, I mean, I keep wanting to say like boogers or something, but like, you know, bits of material on the print that I don't necessarily want to have to clean out super perfectly. It's nice to have a little bit of margin for that. But I think the main thing it's margin for is the button kind of rocking side to side. I don't want it to have a way of binding in there. It's like if you push the button on the very edge and then it kind of tilts over, I don't want that kind of getting stuck on the edge of the tactile switch. So that's one reason to leave more clearance here. Let's just do this by numbers. So here's that edge. That's a 0.5 millimeter, which seems good. I mean, yeah, I think if I plan to have this be about as close as it goes and then have it kind of snap into something and be supported from the other side, let's try that. Oops, that is not the curve I wanted. Let's try it again. Different center point. That looks much better. Curve Boolean. Fill it a little bit. So that's what it would look like. That's at the wrong Z height. That's what I want to put up here. And then, a similar one on the other side. I'm just going to mirror this all once I'm done. Or once I'm done making this part of the shape. Oh geez, that's not what I wanted. Okay, fine. Let me try that again without giving myself a skew plane like that to work with. Really should just do this with projecting everything to the plane. Okay, same thing, but no longer with a slightly weird circle that might have been a problem later. Let's turn off projection. Can't move vertically when everything's projected to z equals 0. Alright, so that's my under support there. Now, I don't really care too much what happens in between here, so I'm probably going to use a loft to make something that looks sensible and printable. But on the bottom side here, I actually want this to come to, I think, a relatively small point here where I can anchor it into the NinjaFlex in a way where it can move down a little bit. So, I mean, it can't come to too small of a point because I do actually want it to have, I mean, yeah, so I guess it needs at least 2 points or kind of a wide line here because, if it was just 1 point in the middle, I wouldn't have any way of distributing force when you press it on this side, for example. So this needs to have a pretty wide base still, but I want to try to get it closer in so that I can make this whole thing a little more flexible. So I think I want the base of this to be not necessarily the width of this whole circle, but more like the width of the actual tactile switch, just to improve flexibility. So I want this to come down to maybe something maybe that long. And it doesn't have to still be curved. It could straighten out to make it easier to attach. And I'm thinking about just something that, well, I guess I'm thinking of different ways to anchor it. I was thinking before that maybe anchoring this by the perimeter is the right way to do it. As I guess part of the goal here is not to over-constrain the button. You want enough to kind of hold it in place, and you don't want it to rattle or anything, but you don't want it to seem too stiff. And if it's over-constrained, then you could end up with it either being harder to press or even pressing itself when you flex the whole assembly. So as far as button travel, this moves down by 0.2 millimeters. Let's see what it looks like to have a base point that's 2 or 0.2 millimeters above this flex circuit board. That's definitely as far down as this can go. And let's actually make it a little bit more than 0.2 millimeters. Because we definitely want the tactile switch to bottom out before this does, but this prevents the switch from, the switch cover from tilting in too extreme a way. Let's see what 0.35 millimeters looks like here. Well, how about 0.45, since that's a multiple of the layer height? And it's also like twice what the switch should need. So it can't come down any further than this. That space below wherever it does come down to also needs to be pretty much free space in the top NinjaFlex cover, because I don't want this to be like compressing NinjaFlex all the way down. I just want it to be like smooth sailing all the way down and then just like bottom out on something that's fairly rigid. So I guess what I'm getting at is it's probably not going to be held on by the bottom. The bottom is just kind of a resting point. The way it's held in might be like a bump on the side. But yeah, I think the right place to hold it in is by the rim up here. So maybe make a cut into this part here and then have like a kind of C-shaped grip that holds onto that. So then this leg here just has to be, a way for it to bottom out safely. It doesn't have to act as an anchoring point. So I think that makes this probably pretty simple. In that case, we just want something that sits on this plane and is just kind of like a linear-ish version of that is still printable. I'm going to start with the center of a rectangle at this corner. I think one of these 0.3 is way too thin. Let's try 0.75. I did want these to be spaced out from the keep outs by a specific amount. Let's do 0.5 millimeters on that line. Do I have room for that? Jeez, where did I just put that line? Okay, it's not quite on the right Z-plane. That's better. Oops. That's not bad. So I want to keep it distant enough from the solder joints that even if this is like rocking and tilting, that it's not going to have much of a chance of hitting the solder joints. I want to give it a pretty wide footprint, both for stability of the buttons and so that it has a pretty wide footprint on the flex circuit board here so that it doesn't, it distributes that force, doesn't mar like a single point too badly. Let's see how that looks. Let's try to turn that into a 3D shape then. Don't want that. So let's just see what happens if we loft these. I think most of this doesn't matter with only 2 sections because it's just doing it fairly straight on. Let's add a 3rd section. Let's also turn on history. I think I do want the very bottom of this to be fairly straight, so I'm going to make a duplicate of this section. And then move it up by 0.6. Ooh, that was a lot. Also, did I not actually copy that? Oh, I did. These are just really hard to see. Let's try 0.45. 0.6 is kind of huge. These seams control how the NURBs are structured, which can be important for editing or when things get kind of stretched out. It can affect the results of the loft operation quite a bit in some cases. Okay, so now you can see this will determine how closely it follows that. Pretty sure you want to lose. Yeah. Cool. Oh. I don't know. I guess the reason I wasn't going to anchor it at the edges is coming back to me that would impact overall flexibility more than if I anchored it somewhere lower. So maybe somewhere along the outsides of these pieces. But I mean, I don't think that's actually going to be... I think anchoring it along the edges is totally what I do want because I want this to have a pretty solid connection to the surrounding NinjaFlex. I just don't necessarily want that to have a solid connection to the bottom. So I think this will need some kind of, collapsible structure in it, but I think the actual anchoring should be really simple and just around this piece. Oh, and I haven't left room for that yet, have I? Can I cut something out of here to make that easier to attach? I think I can. Okay, let's come back to this loft in a sec. I think we can do slightly better. And thick is this? That's 0.6 again. I just need to leave some room here free for that attachment. But I might not actually want to do that everywhere. I want to do that after lofting it. So let's do something similar and make another vertical copy of this. And then use those to control the curvature a bit. I just need to make sure that that is not so steep that it can't be printed. So let's start with this, but then adjust it a little bit. Oh geez, did I not have history on? Let's try that again. Let's keep that on for a sec. Oh, I got that wrong somehow. Sorry, I'm getting annoyed at this and I was getting sloppy about assigning those seams so it ended up backwards. Loft. Okay, those are all going the right direction. Okay, so we got that now. That's better. I'm going to keep an eye on the angles involved here for printability's sake. So let's make a line that's like a 30-degree reference, or 60-degree in that case. That is just barely printable, I think. So maybe on the bottom there. All right, so this will give it a nice strong support. You know, this whole area underneath it could be filled in. This doesn't need to be, I mean, it's kind of a neat shape, but only this middle part needs to be so thin, really. I can keep that though, it seems interesting. It does make it actually potentially, like I'm about to make a cut into this part right here, so I'm thinking about reinforcing the back side of that area a little bit. Yeah, let's actually add a reinforcement to this part. I also kind of want to just go ahead and join these top two pieces. All right. So that is one piece. It's going to be a little bit silly, but whatever. I'm looking at this shape right here. It's a good bit of reinforcement. Failure. How did that Boolean fail? Is this not a close? Oh, that is an open surface. Let's try that again. Boolean still failed. Suspicious of these joints. Let's make a sacrifice to the Boolean onion and move that up by 1/1000 of a millimeter and see if it'll union. That was not a critical dimension anyway. This may not even actually be the problem though. Man, Booleans are so frustrating sometimes. Looks like this edge is kind of ambiguous, and that's the problem. I think that might have been the result of drawing a new circle for that instead of using the same circle. That's a little weird. Can I just subtract this from here? That worked. That did not work. Not a bad shape though. Let's just cut this at the top of the button surface for now. Might have to fix something in there later. I'd like to separate this. Made that a little bit less than 12mm diameter, so that this should cut cleanly when I intersect. Well, those stuck together fine. Alright, so that's my kind of middle portion of the button. This is my foot. And the place that I would like to anchor. So I want to cut out a flat area right about there. 3mm diameter seems nice. And I don't think I want to make these quite so deep, but I do want them to maybe be a little wider. So the whole top surface is going to be up against a flat piece of Ninja Flex. So these are like clips that hold that down onto the flat surface. Or basically, I think they're just going to be little kind of bits of overhang in the material that end up pressing on a flat area here. I worry about printability for this top piece. I mean, not for this plastic, but the Ninja Flex that goes up against it. That's still going to be a big bridge, and it doesn't have to be clean now because it's going to be like in between pieces. It doesn't have to really be presentable, but it needs to at least not be bulgy. So I might have to adjust the geometry of how the keycaps work to have maybe a bit of a dome to them or something. Let's try like a 6mm. That seems fine. It's not pretty as vertices, but I think this will do. And I'll be printing this way around. Oh, let's mirror these and see if I can actually get them to Boolean, and then I think this piece will be ready to print. Cool, so this has the right level of symmetry, I think. It's only symmetric around one axis, and like 180-degree rotation. Oh, non-manifold edges. Where do I find those? Oh, which model is that on? Oh, mesh surgery. Can I maybe just delete this part and have it fill in with a cap? Well, I recapped that part of the mesh. Yeah, so that's the one I fixed. Let's delete the... Did I already delete the other one? Oh no, I just hit it. Okay, will they Boolean? Failure. Do I still have non-manifold edges, or is this just a good old-fashioned geometry problem? No, non-manifold edges there. None there. I might just try making these pieces very slightly smaller in just one dimension. I don't like it when the geometry gets messy like this. The downside of freeform modeling is that you're free to make things as messy as you want. You just have to live with the consequences. But that seemed fun. And these parts do not need to be super high precision anyway, so I'm just scaling them in x and y by 0.99, and then the Boolean succeeds. I think the root cause of this particular Boolean failure is that there were some ambiguous curves around here that ended up intersecting in ways that wouldn't have been representable. But changing the scale of one of the pieces resolves the ambiguity. Okay, so those are unioned. I'll get rid of some of this junk. Do I want to just get rid of all the curves? I think I don't need any of those. Five extrusions and 2 poly surfaces. Great. Here's our poly surface. And now we've got them all over the keypad. They kind of look like snowflakes. So there's enough room to get good button travel. It should avoid all the components on the circuit board. And it has these little bites out of the side that I can use to snap them into the NinjaFlex enclosure. So let's try printing these. This camera could be quiet about its problems. Alright, so we've got some reinforcements here to make it rigid. Nice. Let's look at that in the layer view. This is PLA at 0.15. Oh, that's interesting. This profile has a layer height different than what I expected. I thought that I wonder if they changed this. Oh, or maybe this is Cura not actually loading the settings unless you reselect the material. I've encountered that bug before. Alright, that's more what I was expecting. So 0.15 millimeter layer height. And this won't need any support, won't need a brim even. So 2 layers here, 2 layers of that, and then it starts building up these and kind of straightening them out. So this is a super fast print, so let's just go ahead and make a bunch of these. Let's make, I need 16 of these total, but just because it'd be nice to have some spares, let's make like 20 of them. I think it'll still be a plenty fast print. But they're super easy to damage on account of being so little. It's cute. That is not what I wanted. I don't want you to be Googling for IP addresses. Certainly do more CAD while this prints, although I think I might also take the opportunity to get some tea. And I think I have purple plastic in the printer right now. I guess we can make this next set purple. I still don't quite know what colors I actually want to do, but purple seems like a good one for now. So I think I already cleaned the print bed. I think this is just ready for me to hit print. There we go. Let's adjust cap cam and refill my tea. I might actually catch up on chat. So I've been ignoring that for a bit, sorry. Tuco and I both went to a friend's place for Christmas yesterday. It was nice. Tuco doesn't leave the house super often, but he seems to like a good adventure every so often. There was another suggestion in chat for maybe, maybe a solution that involves using like a plastic mold and then molding silicone around the circuit. That would totally be an option. Definitely different design challenges when trying to make something with NinjaFlex versus molding something flexible. Lovely little creature. Maybe we can do some CAD while these buttons do their thing. Oh, I feel like also might be something where I get a sandwich at some point later and then do a second stream afterwards. Well, let's see how this goes. Okay. So I want to try designing something that this fits into as a test so that I can validate that part, and then we can start kind of replicating and customizing that. So I'm going to start with so this is kind of, the cylinder is kind of maybe a first pass at a region that defines what's inside the button, I think. I want to make sure that there's at least, some amount of material covering over this. I want to make sure there's some material for this to kind of click into. But I'm also worried about printability here. Can't really think of a strategy that's necessarily better than just making this flat and just letting the 3D printer print bridges, but trying to give it a good support around it so that the bridges print successfully. So there also needs to be kind of a part of the NinjaFlex area that can move with the force spreading keycap, but then kind of a loose coupling between that and the rest of it. So that part definitely can't extend super far down. So that's 12 millimeters. Thinking about dimensions here. I mean, the thickness above this can be pretty thin. Like, I think I just need 2 layers, so like 0.3 millimeters. The surrounding, I maybe want it to be a little thicker just so that I can give this a good anchor for doing bridging. So like, what does 0.5 millimeters look like? Well, that's 0.8 millimeters. All right, let's just try making that maybe a full millimeter. I don't think the actual keycaps are going to be this wide, but this will be kind of a necessary part of the support structure to hold up the bridge over the keycap. Yeah, that's what a millimeter looks like. I think that's fine. So then 0.3 millimeters up. Yeah. Usually the Space Mouse is pretty smart, but when you rotate the mode that I have it in, instead of rotating the camera, I'm kind of rotating around a point, and that shows up as this little blue dot. And it's usually pretty smart and just like picks something in the middle of the viewport. But sometimes if I have like if I go over here and I have this object, well, I think since I'm in block mode, it's only picking stuff that's actually in the block, but it's easy to pick a rotation point that is highly unintuitive. In some ways, using the Space Mouse kind of reminds me of flying model helicopters. Excuse me. All right, I think the next consideration is making room for all the electronics. But I also don't want to cut too high up because I want this surround to be as good a support as I can make it for this bridge inside here. But this needs enough room to move down, so let's make a plane 0.2 millimeters, or maybe a little more than that, above this resistor clearance area. 0.2 millimeters is the travel of these buttons. But I want to use a little bit extra for handling kind of weird angles and materials flexing. So that's 0.35 millimeters up. I think we can do more than that. I think the bridge can tolerate a little bit less support. Let's try a 0.5 millimeter. Great, and I think I just want that to pretty much come to let's go that way by 0.5 millimeter. So this is the soft, outer, gooey part that the inner hard part sits in. Now let's check on our print. Still printing away. All right. It's tempting to put more material here, but these do have to go in, so I want to keep this relatively clear, but put some little kind of pins in here that'll easily flex out of the way to snap these in. Alright, that's the flexible part so far. So the goal is that pressure pretty much anywhere in this disc ends up causing the button to actuate. So either it presses close enough that it actuates the button directly, or it causes one of these legs in here to contact the surface of the circuit board, and then makes the rest of this act like a lever to distribute the force to the tactile switch. And then this is this kind of holds on to the tactile piece in an effort to, kind of keep it in place and keep it from rattling around. And it also needs to be kind of loosely coupled to the rest of the flexible material. So I think now is maybe the time to think about another kind of lever contraption, kind of like this thing over here that I built. Oh, where is that? I guess I had that outside of the block, so it's over here. Where do we bring that in? Let's copy that, or cut it. So this was the design last time. The button was a little bit narrower. It had this scoop at the top, which I think we still want to put back in. And this was the kind of collapsible part. There sure are some noises happening on the roof. Let's just get this circle back. And what else? We have the surface of the circuit board. So that 30-degree reference is what I've been using for kind of the steepest overhang I want to try to build. It's like what this line is. And the power tools on the roof also kind of make me want to go take a walk and get a sandwich soon. Oh, did the printer fail? Let me check that again. There's a couple. Yeah, maybe some insufficient stiction. Let me check that in person. Okay, I think my Z height might have been slightly too high. I think I adjusted it while it was doing Ninja Flex, and then this stuff is a lot more sensitive to Z height. But aside from the couple of them that failed, the design actually looks like it prints fine. Let's take a closer look at these, possibly even under the microscope, because they're pretty little. So here are the ones. Here are a few that just came out of the printer. Still got some trash attached to one of these. But yeah, nice, flat surface on one side. And then these kind of focus. All right, yeah. So got the flat surface, got the underside with these kind of height limiting pieces, and maybe not autofocus. And then this kind of little hexagonal reinforcement pattern. Let's try these on the buttons briefly. They're not really gonna, this isn't really gonna be a good test without the surround because there's nothing to keep these lined up, but we can at least try it. So they'll fit somewhat like that. It's pretty straightforward. And it would be nice if there was an easy way to rigidly prevent these from moving up on the right side, because notice how I'm having to hold it down for that lever to actuate. A lot of this is going to be different with the Ninja Flex piece on though, so maybe we should go ahead and make a test piece for that. Alright, back back to this. How much space do I have? I guess it makes sense to have that. I guess I'm thinking about how much to sort of fold the springy part here. Looks like there's the lowest it can go. Those, how am I going to support that? Well, I think I'm trying to combine too many things into one drawing here. Let me maybe first model the top with the kind of curve in it. And then I think this support piece, I'm only going to revolve part of the way around, just like from here to there and from there to there on the other side. Hey, Tuco. What do you want, cat? Oh, there's a suggestion from chat that I could bond the NinjaFlex to the PCB afterwards to prevent it from lifting. I do plan on doing that. I plan on gluing it all together to keep it flat. I'd also thought about having pins that come up for heat staking, or otherwise thermally welding it together. But I think there's just not enough free space with all the buttons and magnets and stuff. I think it's going to have to be glued together. But I'm not really too bothered about it being hard to take apart. It's a little nicer. Button cap, button underside, Boolean union. And now I just need to make this printable so that it doesn't just hang in midair. So this is going to be, that's going to be annoying. Alright, I guess I probably need part of my support like over here and here too, because otherwise this bridge is not going to be printable. now. Yeah, I really do want to support all the way under there. What kind of tool even is that? So I need to support that, but, well, if that material existed, I would need to support it there, but there isn't nearly enough room to build the kind of lever that I need to make it still flexible, so I think I need to remove that material. Let's see what I can safely remove. So, I mean, this area around each side needs to be pretty solid, and I need to keep this top ring fairly solid, but the rest of this material I can cut away if it's helpful. Maybe I need to modify this to make it easier to print, because this bridge is going to be a problem. There's, like, when it prints this layer, the first layer of this curved piece, there's not going to really be anything to anchor. So if you look straight across, you can't just draw a filament straight across there, and it would have to anchor to something that doesn't exist. So that's a problem. So I just kind of cut that curve short or something. Yeah, let's try something with that maybe. Good idea. Sure. Not quite. I'm just going to make something I can cut there. It's like about a 45-degree angle anyway. Hey, Tuco. What do you want, little tiger? You want to be the star of the show? You probably want something tangible. Yeah. Hey, Tuco. Okay, maybe This would be easier with a polygon. This would be easier with a polygon that's planar. Yeah, that's kind of what I'm going for. So that's still supported underneath. Yeah, I mean, this isn't on the side where the supports are, so it's okay to kind of cut some material here. And this should have plenty of layers in order to get a solid base for the edge of the tactile part of the button. So let's just put this on the other side too. Hey Chico, do you want to go outside? I think he's scratching at the door. I'm gonna go let Tuco out into the hallway. He seems to want to explore. CAD is popular on the internet and in this warehouse. That looks more printable now. A little bit. So actually, I think I want to change this slightly still. Like, let's just start this over. Oops. Oh. Help if I actually had all the line segments I wanted. That's better. I think that does actually need to be straight down. Yeah. Okay, now I've got a little bit of a lip there to help it make this bridge without having to worry about immediately expanding upward. What is that? Okay, I don't want that breaking through right there. It's tempting to also trim off the edges of that plastic piece, or the hard plastic piece, but I think I'm going to do that slightly differently. I hear you, Tuco. I think that's all I care to fuss with this. I mean, that spot right there is going to be really thin, and I think it's fine. I just worry that it's going to cause printing issues later. But I probably should worry about different things for now. I could do that and make it more decisive. Hey, Tuco. that also cuts off those edges that would have not really printed right either. And it'll open up that hole, but that should be fine. It'll at least open it up by kind of a decisive amount. And then I've got an overhang that should be printable. Let's try that. Oh, huh. What is going on in there? Oh, maybe I just haven't gotten around to subtracting out that cylinder and it just needs that to be done. Let's see if I can just do that. Let's try a simpler shape. I hear you, Tuco. How was the hallway? It seems better. Great. That's what I wanted. I forgot I had not already subtracted that part. I'm just kind of inspecting the printability of the structure, thinking about how it'll be made layer by layer. I think that'll be alright, but of course this is kind of crazy and so it'll need some testing. And I still need to build the kind of lever part that actually holds this. So I think so far mostly all I've done to this is make it hold the inner part, make it look the way it's supposed to on the top, and make it hopefully printable. But it's still kind of floating. I need to figure out how much of this bottom part I can remove and how to support what's left. Back inside this block. All right. That might be all right. I do want to kind of copy some of the dimensions from this piece. Like the thickness there was good, that was 6 millimeters. So let's make a copy of this and then move it 0.6 up. Or yeah, not 6 millimeters, 0.6 millimeters. Oh, I guess I did not successfully move just one of those copies. I moved both of them. Oh, history update, right. Let's turn that off. Okay. So then this part, yeah, the other thickness is, so I guess this was kind of another support piece. That was a 0.5 millimeter. And then 0.3 millimeters for the actual lever piece. Oh, how did record history get back on? Let's turn that off. I think if I move, so this corner right here, I think that defines the boundary of, well, it's kind of hard to see in this. My working plane's way over there. Okay. All right. All right, so copy that. Oh, I really want to move that in the curves coordinate system. this is going to be roughly where kind of the main support lever goes, because it needs to support the actual clicky part up here. And I need to, during printing at least, find a good way to support this piece. And this is kind of the maximum overhang angle I'm allowing myself here. And this outer line is kind of where I can start to remove that material once it gets farther out here. And then this is our floor level. Alright, I'm also going to make another kind of 30-degree angle, but going the other direction. Oops, not 180 degrees, 90 degrees. Actually, not 90 degrees either. Mirrored. Okay. So I think one of the first things I will do here is kind of take out this chunk of material. And then leave this as kind of a lever base. Oh, it's way over here. Let's let's change the plane and then project it to that. That's not what I wanted. Okay, that's the step I was trying to take. Not cut away way too much material. I'm just taking a look at what's going on. Sure are some noises coming out. Chico's in the kitchen eating right now. And the grinders on the roof continue. So this is mostly a printability concern right now. Like, I'm trying to, over here, simultaneously make sure that this whole thing is printable and try to make a good squishable lever for the button over here. And then over here, I'm not so concerned about the mechanics of the button. I mostly just want to make sure everything prints fine. But this side has, like, I need to carefully support like this corner of the bridge, like each of those side corners, and this doesn't really do that. What does that end up looking like? That might still work. I think that gives enough space vertically to support. So I think that'll support this piece, and I think it'll still serve the other functions. Let's see what this looks like when I mirror, and then do the subtraction. It just comes in too close. I mean, that'll be a start. Mostly I just want to make something that has this kind of a crease in it and is compatible with this entire surface all around. I want it to be below that point and far enough from that point. Let's see what that looks like. How did I meant to do that 360, not 180. Okay, that's better. Okay, it really can't disturb that. That's a problem. So I need to make sure that doesn't touch that corner right there. Oh, why is my phone buzzing? I really need my phone not to be buzzing at me right now. Yeah. That's really not even much of a ding, is it? I might have to do more of this. I think I want to make a cut into this side. Just thinking about where this whole thing has to be supported from. It's like, I think right now, if it was printing on a flat surface, this would all be printable. But, you know, that clearly is not going to be the case. This is going to be part of a different thing that's kind of hovering. So... Yeah, maybe let's not worry about that top cut yet and just focus on this bottom cut. Oh, that's not what I wanted. Oh man, let's like only have one of these buttons visible maybe. Alright, so that's the plastic insert. And that's the Ninja Flex piece. It's looking better. So I think this is what's actually going to support it on the outside. Yeah, maybe that is all it needs, and then taking out whatever material I can take out safely from here, which maybe means using a shape like this, but then stopping it when it gets close to here. And that doesn't need to go in super far. It's way over there. So that'll support, or at least be part of the support for this edge, but I don't want like these pieces at all. So I'm going to trim that. Alright, starting to see this come together. Alright. Get rid of all that. Alright, so we have the outer piece, electronics, and the little plastic piece. I think I actually wanted to do... Huh. Sometimes object visibility in Rhino is a little weird. Anyway. So let's take a look at just that piece. So it has these little doodads to hold in the hard plastic bit. Oh, that's not supposed to be there at all. I should take that out. That's a problem, isn't it? So, I guess I had those for a reason, like they help with the printability. But they also cover up where the insert needed to go. Oh, I mean, this isn't the worst thing. It's just not what I wanted. Since that piece kind of needs to be there in order to support printing what's over here. If I just take this away, then this is not a printable bridge anymore, because there's nothing supporting it. So, I think I need to basically move that support a little further out so that it doesn't overlap with where the insert goes. It's also really tempting to fill this part in and cut off kind of that edge of the insert and make them flat on two sides, because that would also improve this printability problem quite a bit. Well, let's go ahead and take those off again. Or did I already? Fine. Like, I could try continuing that curve over, but I think that's still too much of a overhang. Okay, let's have a, I think what I want to do is set my C-plane to world, front, and then make it pass through that point. Yeah. And I want to support this thing. So I think this is the area we want to keep clear in the middle. Yeah, I think that's all I need. Just that and this, and then some stuff on top, and cutting this extra. I think I maybe wanted some of those cylinders I had before. It's fine. Still wanted that other cylinder also. It's fine. Okay. That's the piece I want. That's the piece I don't. Go ahead and attach these two. I mean, I could have made that much simpler, but this is fine. Can it Boolean? Can it Boolean? This is not looking good. Boolean failure. This is a little bit hairy. I mean, I want to fill in that area, and I want to get rid of this part. Yeah, I think I need to manually cut that off first. I didn't save the profile for that, did I? Let's get the profile for this shape back. That's a pretty tight spot right there. Not sure that's what I want either. Yeah. I might get to the point where I can try printing something soon. I think I'm also feeling sandwich-related frustration set in. I think I might need to go get some food in a sec and think about this along the walk. I mean, design is clearly a big mess, and I could simplify it a lot if I had a better idea of what I was doing. But part of what I'm doing here is just trying stuff to see what actually works. There's definitely a lot of compromises between printability and getting the right structure that I want, but that's fun. I think this is super fun. I guess the goal here is mostly just to make those openings something I can support as kind of an arch like this. Let's see, I think I was just going to use this to cut the bottom off of that. And I got distracted by how tight this corner is, because that's just a terrible corner. All right. that's pretty much what we want. If I can get this to union into everything else, and then clean up the edge that's way too thin, and then see if there's any other material I can remove. It does Boolean, yay. Alright, so these cutouts are for the electronics on the board. This joint is what we're turning into the kind of bendy lever part, but it's not quite there yet. And then this is another printability hack. We can take a look at that in Cura, because this is certainly getting complicated. Oh, geez. Yeah, that was an unintended cut there. Let me put that material back. Okay. Seems like an improvement. I will go ahead and chamfer. I don't know if that's quite enough, but I think the next thing I want to do is try to cut out as much of the side material as possible so that it can compress, like specifically right in here. just make that plainer. And the plane is way over there, which isn't quite what I wanted, but it's fine for now. Where is the thing I was just working on? Way over there. Somehow the world plane and the plane for this object are kind of far away. Probably would have been easier to work on one close to the origin. Oh. Okay. I made a mistake here and came in a little too far because most of this is not nearly as far in as the little nubs here. Let's go back a little. wasn't any more helpful. Okay, I guess I expected there to be a wire there in the wireframe, but there isn't. There is actually an edge right there. Great. Curve Boolean projected it way over there, which wasn't quite what I wanted. And then it's easier to do the revolve if I do it around the C-plane z-axis. So now I'm back here. Okay. So I think the way to solve this problem on the edge is just not to cut it away from the area right around these openings. I actually wanted a chamfer there, not a fillet. That's not going to work. Let's try something else. Yeah, I want to see how this looks in Cura. I think there's a spot where the wall is too thin and it's not printing right here. Otherwise, this seems like it might actually work. Okay, so that hole we're looking at is right there. Oh yeah. I think we can just move that out a little bit. Still got some small holes there. Might be a geometry problem, I don't know. Let's take a closer look at that. It's like this area. Yeah, I guess it is just that. Alright, let's back it up a little bit. Might need to cut out more material, but let's just test this. That seems better. It's going to be a tricky print, but I think it's ready. And I'm definitely ready to go get a sandwich. Okay. Oh, there we go. That's the right camera. Oh, Tuco's way back there. I don't know if you can see him. Hey there, cat. Oh. So this should be a pretty short print. We can at least take a look at how it works. Then I think I will be wrapping up the stream right after this because I've got to get something to eat. So this printer is a Type A Series 1. The bed is the standard glass bed that it came with, plus a sheet of that yellow PEI. Oh, I have a... I was about to mention my heating hack where I don't actually have a heated bed, but I put like a foot warming mat under it to help it adhere. I think I forgot to turn that on, which might have been one of the reasons for the for the earlier pieces not sticking completely. But the Ninja Flex sticks super easily, so I'm not really worried about that. Sticking is not the problem with the Ninja Flex. The problems with the Ninja Flex usually have to do with extruder jams. You've got some nested stream action there. You can kind of see the other copy of us. There's a question in chat about what I'm going to eat. I'm probably going to walk down the street to this sandwich shop that I like. They have really good vegetarian sandwiches. I have some food here, but I think I really want one of those sandwiches, and that seems tastier and probably more nutritious than most of the things I have around here. Oh, CAD is really into these head scratches. Or rather, I think this is more like a neck massage. I'm still not sure if Tuco liked his trip to my friend's house yesterday. Because he likes adventure quite a bit, but he seemed to spend most of this trip, hiding under the bed rather than exploring. He seemed to like it better when some of the party folks left and it was a little bit quieter. Kat and I are both kind of introverts like that. Oh, now he's back in his usual spot. There's a question from chat. Actually, a couple questions. One is if I live here, and yeah, I live and I work here. I'm pretty lucky that I get to do that. I mean, this might not be the ideal living space for a lot of people because it's right next to a train, and it can be kind of cold and kind of noisy, but it's pretty much exactly what I want. Before I found this place, I had this dream of kind of moving into a concrete box. And there were really just three things I wanted: the concrete box, a laser cutter, and of course a place for just me and my cat to live. I still don't have a laser cutter, but I think I might get one of those at some point this coming year. The concrete box has been really nice. So it's kind of a mixed-use industrial zone. This place, it's like a big warehouse building that used to be a cable factory, like making bridge cables and stuff. And now it does a lot of different things. There's like a factory downstairs that makes like rice mochi. There's like yoga studios and hair salons and stuff like that. But it's still very warehousey. The hallway is just like a big concrete floor corridor. It's super long. It's nice here. The other question from chat is whether Tuco purrs. Tuco does purr. Tuco makes all sorts of great noises. He makes little chirping noises at things that he wants to catch, like birds and plastic bolts. He definitely purrs when he's really happy. I think right now he isn't purring, but I think he's still kind of settling into this location. He purrs pretty quietly. He makes a lot of other noises loudly, like, he chirps and meows, and I've even heard him bark once. And he can be very vocal with that kind of thing. His purrs are usually quieter, but I really like just putting my ear up to his tummy and listening to him purr when I'm petting him. It's the best thing. Let's see if I can tweak this camera angle very slightly. It would be really nice if that camera had like a zoom and a backlight compensation. Because this camera helps with a lot of the kind of printability issues I have with like the first layer adhering, but like as you can see there's a lot of glare and it doesn't focus super well, so I might have to adjust that situation. It makes for really good time lapses with this camera, but the positioning is not necessarily great for seeing the details of the actual print progress. Oh, there's another question. If I changed my style because I'm tired? I'm wearing a different hoodie today. I mean, and I have my hair up. I guess there's some differences. I do change clothes occasionally. I think mostly my clothing right now is related to the temperature rather than my level of tiredness. I was, well, since I was, out most of yesterday at my friend's place, I turned the heat off while I was gone and got back late, and it was cold, and so I didn't really turn the heat up much in the shop. I think I just went to bed. And then tried to turn the heat on in the morning, and then I think I just like not noticed that the pilot light was out, so it was like 11 a.m. or something, and I'm like, oh man, the shop is still really cold. And then I look at the heater and the pilot light's out, so I have to fix that. And I don't really like running the heater that much here because oh, it's finished. the warehouse here just like it's so drafty and it leaks so much. There's single pane windows everywhere and gaps in the windows where they don't quite close all the way, and so I don't necessarily like just pouring energy out, but it does help to have a living environment that is a good temperature for humans and cats. So let's get this part and see how it works, and then wrap up this stream. Oh, this piece is so tiny and delicate compared to the previous models. So from the top it actually looks really nice. Let's get a better camera view. Alright, so here is the piece we just printed. Looks pretty alright from the top. Hard to tell how well this bridging worked. Like it feels relatively flat actually, which is kind of a pleasant surprise. Like this, clearly it's a little bit ragged in the very middle, but I think it might actually hold the insert in place. And there's little nubs. And the top of the button feels pretty good. So let's try putting in one of these inserts that printed relatively successfully. Not sure the rim this is supposed to fit in is totally clear, so it might be... It feels like it's stretching a little bit to fit in, and it hasn't quite like snapped into place. But yeah, here we go. So you can tell that the insert is stretching the outside a little bit, like it's causing it to kind of bowl shape like this. It does look more like a hat now. So I could fix that by making the groove a little wider, or it might not even be an issue once this is assembled. Oops, sorry lens. But the top of that button actually feels really good now with the insert in. And let's put it down. these magnets be in the way, maybe have them help. Something more like that. Ooh, that's kind of nice. So centering should be less of a big deal now that we have kind of a big pad that can slide around on the tactile switch if it needs to. I'd really like to finish this project today. I'll probably work on it some more. I'll try to stream that if I can too, so there might be another stream later. There's a little bit of an extra string I want to cut off. It's really hard to just like pull off extra strings on NinjaFlex because it's so sticky, or so stretchy rather. That feels pretty satisfying. Let's try the pencil test. The magnets are not quite holding it flat enough for that test to work. If I hold it a little extra though, it kind of works way at the edge. Right there it works pretty reliably. Yeah, it might be time to print maybe a bigger test piece with that I can lay across all the buttons at some point. This is missing a couple of features. I think maybe the next thing to do is to print still just a single button, but maybe like a slightly larger scale test where I also include the surround, because this isn't quite like the finished, like I want, where's my example? So on this button, this has a surround that comes up cleanly to kind of hide the folding mechanism under there. Whereas like this button has that part of it, not that button, that button, that button just didn't print right. This button though has the fold exposed. So, and I don't want that to be exposed, and that's also a really weak point, so I want to protect it and just allow the button to be pressed and not to be ripped off. So, yeah, I think that plus a pretty basic surround will help. Yeah, the other problem is when I press the button with my finger too far from the center, normally I would end up forming another lever between that rigid surround and, you know, like something maybe a quarter of the way into the radius here. But instead I just end up kind of like rolling off the button, so that's another reason for the rigid surround. But other than that missing piece, this is much better, and it's also much flatter. Let's take a look at that. Yeah, I think that's centered-ish. So it feels pretty good. Definitely a step in the right direction. All right, thanks for tuning in, everyone. I'll pick this up in a bit after I have a chance to collect myself and eat some doodads. But yeah, more CAD and printing later. Thanks for joining, everyone.